All right, good morning, everyone. Today we're going to start talking about geometry and trig geometry. So that has to do with angles and triangles. And today we're going to start talking about the special triangles. And there's two special triangles we'll talk about in a little bit. But first, we're going to kind of review a little bit of trig information from grade 10. So if we have a triangle, a nice right-angled triangle, something like that. It's got a nice right angle in it. And we're looking at some angle on it. We'll call that theta. Then we label all of the sides in reference to this angle. So we have three sides, 1, 2, 3, and we label them as such. So the one that's on the opposite side of our angle, we label opposite. And I'm just going to write op for now. The one opposite of the right angle is always the hypotenuse. And the remaining one, which is the one that's beside the angle, we label as adjacent. I mean, adjacent kind of means beside, so that makes sense. So it's the one that's beside, that's not the hypotenuse. So those are the three sides, and it's always in reference to whatever angle we're looking at. So if we were looking from the perspective of this angle in the top of our triangle, the hypotenuse would stay the same, but the opposite and adjacent would be different, right? This bottom side would be the opposite of this top angle, and this side beside it to the left would be the adjacent. So it's always in reference to whatever angle we're looking at, from whose perspective we're looking at. Okay. We also had what are called the primary trig ratios. Okay. And those are sine of the angle, cosine of the angle, and tan of the angle. Okay. And these things, sine, cos, and tan, when we do the operations of the angle, they give us a ratio of the side lengths, which is basically telling us how the proportional difference in the lengths of the sides. Okay. And sine theta gives us the opposite over the hypotenuse. And you may remember these ratios. There's like an acronym that maybe you learned last year called SOHCAHTOA. SOHCAHTOA. SOHCAHTOA helps us remember which one is associated with which. What ratio of side lengths is equivalent to which one. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tan is opposite over adjacent. Opposite over adjacent. Okay, now I hope you're fairly familiar with these and working with these. We'll work with them throughout the course, so we'll get some refreshers on them. But there's three other ones we're going to talk about today as well. And those are called the reciprocal trig ratios. And this word reciprocal is probably something you've seen before, right? Reciprocal is when we take a fraction, we flip it upside down. And each of these trig ratios is related to one of the primary trig ratios, and it's just the flip of it. Okay. So the first one we're going to look at is called cosecant. We represent a CSC of the angle. And that's the reciprocal of sine. So it's 1 over sine theta. For the side lengths, it would just be the reciprocal of sine. So it's hypotenuse over opposite. Okay. So that's the first one. It's called cosecant. The second one is called secant. Secant theta. And that is 1 over cosine. It's a reciprocal trig ratio for cosine. So it is the reciprocal of cosine. If cosine is adjacent over hypotenuse, secant, is hypotenuse over adjacent. The last one is cotan, or cotangent theta. And this one's the reciprocal of tan. It's 1 over tan theta. And tan's opposite over adjacent, and cotan is adjacent over opposite. Now, you may or may not find these trig ratios on your calculators. Okay, they do come up a number of times, and we'll see them throughout this course, and you may see them in future courses as well. But generally, we translate between these two versions. So if we have a cotan, we translate it into 1 over tan. If we have a secant, we translate it to 1 over cosine. So we need to know which one associates to which. And there's a bit of a trick to that. And the trick I always use is I always look at the second consonant. So the second one for cosecant is s, and it's for sine. So 1 over sine. The second consonant, well, the first one's s, and the e is a vowel. C is a consonant. Second consonant, 1 over cosine. So C, the cosine, they match up. And last one for cotan, T matches up. So that's kind of how I remember. Different tricks people use. But that's what I use to remember them. Okay. So now we're going to look at these special triangles. Let me switch colors here. So the first triangle we're going to look at is called the 45-degree right isosceles triangle. And it is, as described, a right isosceles. Isosceles just means two of the side lengths are the same. It's a right angle triangle. It's got 45 degrees in it. So we're going to draw a quick sketch of it. Okay, so our side length should be approximately the same. And it's got a right angle in it. And then each of these angles is 45 degrees. Okay. So we're going to label the side lengths of this triangle. And of course, depending on what side lengths are, defines the other side lengths as well. But when we're using these special triangles, we always label the sides with the shortest side lengths being 1. So the shortest side lengths for this triangle are both of these arms here are both the same length, so we're going to label them 1, 1. And the hypotenuse here would be 1 squared plus 1 squared is 2, and then we square root it, right? So we can use Pythagorean theorem to calculate it, and it's the square root of 2. Okay. So some people call this the 45-degree right isosceles triangle. Some people call it the 1, 1 root 2 triangle. That's another way to remember it. Okay, those are the side lengths. Okay. And we can use this triangle to find the trig ratio for a bunch of angle for all the we can find the trig ratio for all the ratios for 45 degrees. So let's do that. So it doesn't matter which perspective we take because it's an isosceles triangle, they're the same, but I'm going to always use this bottom one here, this 45 degrees at the bottom of our triangle. So sine, remember, is opposite over hypotenuse. So opposite is 1, hypotenuse is root 2. So sine of 45 degrees is 1 over root 2. And that is an exact answer. If you take your calculator out and you make sure your calculator is in degrees and you type sine 45, some people's calculators might say 1 over root 2. Most people's calculators probably say like 0.707, etc., etc. Right? And that's a lot of decimals, but 1 over root 2 is an exact version. So cosine 45, so adjacent would be 1, hypotenuse is root 2, 1 over root 2. And tan of 45 is opposite over adjacent, which is 1 over 1, which is just 1. Okay, so now we need the reciprocal ratios. So let's recall that cosecant is 1 over sine, so it's the reciprocal of sine 45. So sine 45 is 1 over root 2, so cosecant 45 is going to be root 2 over 1. And you may or may not write the over 1 part. You don't need to write the divide by 1 for a fraction usually. So secant is the reciprocal of cosine, so we'll flip that one. We get root 2. And cotan is the reciprocal of tan. Reciprocal of 1 is just 1. And these are the all the trig ratios for 45 degrees. So let's do the next triangle. So the next triangle is called the 30, 60, 90 triangle. It has some other names people call it, but I think this is the easiest one because that's all of the angles in the triangle. So it looks a little bit different. It's got a shorter side and then a longer side and then the hypotenuse. It's got a right angle. and the angles are 30 degrees, 60 degrees, and 90 degrees. The right angle is the 90 degrees. The 30 degrees is the smaller angle from our diagram, so that's 30. And the larger angle is our 60. Okay. Now it's a bit more tricky to come up with the side lengths for this one. But the shortest side length is always 1, and it's opposite the shortest angle, which is going to be this side here, 1. There's some tricks to how to find the other side lengths, but you can just memorize them. So the hypotenuse is 2, and the opposite of the 60 is the square root of 3. All right. So this is the 30, 60, 90 triangle, and this is the 45-degree right isosceles triangle. Now, we're going to write down all the trig ratios for 30 degrees and all the trig ratios for 60 degrees. And you do not need to memorize all those trig ratios. That's way too many. That's a total of, what's that, 18 trig ratios? That's a lot to memorize. I don't think I could do that. But what we do need to know is we need to know SOHCAHTOA. We need to know which reciprocal is for which primary trig ratio. And we need to know these special triangles. And then when we know those, we can come up with any of these responses, any of these trig ratios. So we'll need to memorize, and we'll practice, and we'll use them a bunch, these special triangles. They're very common. They show up all over the place in future mathematics. So we should know them. And these reciprocal trig ratios, we need to know which one associates to which. All right, let's go through and let's do let's do all the trig ratios for 30 degrees. So we're taking the perspective of our 30-degree angle here, and sine is opposite over hypotenuse. So opposite of 30 is 1, hypotenuse is 2. Cosine is adjacent over hypotenuse, so that's going to be root 3 over 2. Tan is opposite over adjacent for 30 degrees, so 1 over root 3. And now our reciprocal ratios, so cosecant is the reciprocal of sine. So in this case, it's going to just be 2 over 1, or 2. Secant is reciprocal of cosine, so it's going to be 2 over root 3. Cotan of 30 degrees is reciprocal of tan, is just going to be root 3. All right, so we're just using the triangle and looking at all of opposite over hypotenuse to find sine, adjacent over hypotenuse to find cosine, opposite over adjacent to find tan. And the reciprocals, we just use the sine, the cosine, the tan to find the reciprocals. You can memorize that cosecant is hypotenuse over opposite, but to me that's more challenging than just remembering it associates with sine, and that's the reciprocal of it. Okay, let's do the 60 degrees. Okay, so for 60 degrees, sine is opposite over hypotenuse, so root 3 over 2. Cosine is adjacent over hypotenuse, 1 over 2. Tan is opposite over adjacent, which is root 3. Cosecant is a reciprocal of sine, so it's going to be 2 over root 3. Secant is reciprocal of cos, is 2. And cot 60 is going to be the reciprocal of tan 60, which is going to be 1 over root 3. Okay, so that's all of the 18 trig ratios for 30 degrees, 60 degrees, and 45 degrees. Okay, so let's see how we can use those every once in a while. So here, for this first example, we want to know what the angle is. That gives, when I take the sine of it, I get 1 over root 2. Okay, so we could look. So sine of 30 degrees gives me 1 over 2. Sine of 60 degrees gives me root 3 over 2. And sine of 45 gives me 1 over root 2. Okay, so then the angle must be 45 degrees. So we can say theta is 45 degrees. Okay. Now, we might not always have all of these trig ratios written out fully, but we can look at the triangles as well. So if I think what angle sine is opposite over hypotenuse gives me 1 over root 2. So I need opposite over hypotenuse to be 1 over root 2. So 1 over 2, that's not right. 1 over, root 3 over 2, that's not right. For 45 degrees, 1 over root 2, that's what I want. So 45 degrees sine 1 over root 2 would be for 45 degrees. So we don't necessarily use this table to find stuff. Okay. For example, this time, let's not look at the table. Let's just look at the special triangles. And actually, when you do your practice, the goal is for you to use the special triangles for each question. You can look at the table if you really want, if you really need to, if you're stuck or if you want to double check something, but the goal is to just use the special triangles. Okay. Excuse me. So we're going to find the exact trig ratio for secant 30 degrees. So exact, we've seen that before, right? We want fractions, we want radicals in it. So we get, no, we don't want decimals for the most part. So exact for secant 30 degrees. So secant, well, what's that one? Well, that's 1 over cosine, right? 1 over cos. And cosine was adjacent over hypotenuse, which means this is going to be hypotenuse over adjacent, the reciprocal. So we're looking for what is, we want to look at 30 degrees and find out what hypotenuse over adjacent is. So let's go up to our triangle. So 30 degrees hypotenuse over adjacent. So we looked at 30 degrees, so 2 over root 3. So we can say secant 30 degrees is, I forget already, scroll back up, 2 over root 3. 2 over root 3. We could check our table as well. Secant 30 degrees, yeah, we wrote down earlier that that is 2 over root 3 as well. All right, that's it for this lesson.